Welcome to lesson 9.3, which is on our second main type of sequence, a geometric sequence. So far we've done arithmetic sequences. To work with those, we needed to know A0 and D, the common difference. For geometric, we also need to know two things, but we're actually going to be using A1 and R, which is the common ratio. So for arithmetic, you had a common difference. That's where you figured out what each term went up by or down by from one term to the next. For geometric, you're going to find a common ratio, and that's going to be what you multiply by to go from one term to the next. You can find a common ratio simply by doing division, because you're going to write it as a ratio, which looks like a fraction, which is really a division problem. So we'll be doing division to find a common ratio. There are two formulas to work with, one recursive, and that's very simple. Take a sub n and set it equal to the term before it, a sub n minus 1, and then multiply by r. You got to know what a1 is. And then explicit, take a sub 1 and multiply by r, the n minus 1. And so those are our two main formulas to work with, recursive and explicit. Problem 1. Is the sequence geometric? If it is, what are A1 and R? Well, I'm looking at problem 1, and I want to see if it has a common ratio. So all I do, for a common ratio, you take a term and divide by one that's to the left of it. That's how you figure it out. So a sub n minus 1 is to the left of a sub n. So take a term. You can't start with 3 because nothing's to the left of it. So we'll start with 6, divide by what's to the left, 3, and you get 2. Go again. Take 12, divide by 6, and you get 2. 24 divided by 12 is 2. And then finally, 48 divided by 24 is 2. This has a common ratio. It's 2. So what is R? R is 2. What's A1? A1 is the first term, which is 3. If I was going to write an explicit function for this, explicit formula would be a sub n equals, and I just plug in what I know. A1 is 3, R is 2. Now what you might want to do to play it safe is always put R in parentheses, because if R is negative, you need to have parentheses, so maybe you just want to go ahead and put the parentheses there, and that would be good to go. If I was going to do a recursive one, that would be a sub n equals a sub n minus 1 times r, and r again is 2, and then you tell me what a1 is. So that's all there is to recursive. B, want to find the ratio to see if it's common between consecutive terms. So I'm going to do 6 divided by 3 is 2, 9 divided by 6 is 3 halves, or 1 1/2, 12 divided by 9, well, that's 4/3, or 1 1/3. 15 divided by 12, that's 5/4, or 1 1/4. They're not common. There's not a common R. They each have a different ratio. So no common R, no common ratio. So not geometric. And hopefully when you first looked at this, you said, wait a minute, that's not geometric, that's arithmetic, because I can see it goes up by 3s. You go up by the same amount, then it's arithmetic. We add or subtract by the same amount. And just a reminder for arithmetic for you. A sub n equals a sub 0 plus dn. Well, a0 is 0. That's the term that's where it would be in this b spot right here. That'd be 0 because I got to go 3 left, and it'd be plus 3n. So it'd be a sub n equals 3, and that's the arithmetic, explicit arithmetic. Recursive would be a sub n equals a sub n minus 1 plus 3, and a1 is 3. That would be recursive. So just a reminder for you there. One on the left, explicit, one on the right, recursive. All right, C. Ratio, 3 to the 10th over 3 to the 5th. Bases are the same, so you go ahead and subtract exponents, and you get 10 minus 5 is 5. 3 to the 15th over 3 to the 10th would be the next one. Bases are the same. 15 minus 10 is 5. So I got 3 to the 5th again. And if you do 3 to the 20th over 3 to the 15th, you get 3 to the 5th again. So that one does have a common ratio. It's 3 to the 5th. If I was going to have you apply this and come up with a formula, you could say A1 is 3 to the 5th. R is 3 to the 5th. I got to take it to the n minus 1. And do something cool here to show you that all our work with exponents didn't go to waste. Let's simplify this. I can multiply these and turn it into 3 to the 5n minus 5. That's how I simplify that. Minus 3 to the 5th. Now bases are the same, so I can go ahead and add exponents, and that turns into 3 to the 5n. Because the 5 and negative 5 cancel. So this is a simplified version of that. So you might have a right answer, but maybe the back of the book has something different, or a friend has something different. They might have simplified further than you did. They might have combined exponents because they saw like bases. Okay, indicated terms of the geometric sequence. I'm telling you it's geometric. We're going to find a 10th term. If it's geometric, you need to know two things, A1 and R. Well, A1 is 4. Halfway there. All I need to know is R. Well, R is what you get when you take a term and divide what's to the left of it. And you see, no matter which ones I use, I get R is 3. So there's your geometric pattern, geometric rule or formula. To find a 10th term, that means I'm going to find a sub 10. Simply plug in a 10. So we need to do 4 times 3 to the 9th to get the 10th term. Plug that in your calculator. Take a second to type that in myself. I should remember it. So I had 4 times today. 4 times 3 to 9, 78,732. That's the 10th term. Okay, here we got second and third term. Looks a little different, but really, it's not all that different. You got to know what I'm giving you. Just tell me what I'm giving you. And 2 is the first term, so I can say A1 is 2. And negative 54 is the fourth term. So I can go ahead and use the formula. And I know A1, that's 2. I just need to find R. But I don't know R, and it's kind of hard to figure out, but mentally anyways. But what I can do is plug in what I know. And what I know is 4, when I plug in 4 for n, I should get negative 54 for an answer. If I plug in 4, I should get negative 54. So that gives me an equation to work with that allows me to solve for R because that's the only variable in the problem. Let's see if that makes sense. To go from 2 to this spot, I need to multiply by some R. And to go from that spot to the next, I need to multiply by some R. And then I multiply by some R to get to negative 54. Therefore, I should end up with 2 times R times R times R equaling negative 54. Well, R times R times R is just the R cubed that I have down here. Okay, so let's solve this. Divide by 2. And I get R cubed equals negative 27. How do you solve for R? Third root. So R is negative 3. So I've got my R, I've got my A1. Now I can get my formula. A sub n equals 2 times. You have to have the parentheses here. You're going to get it wrong. Negative 3 to the n minus 1. If I want to find the second term, that's A sub 2. I can simply plug in a 2 right here. All right, so I kind of got interrupted there. Let's see, I was talking about A2, A3. So anyways, A2, You can find simply by taking and multiplying 2 by -3. That gets you -6. And then A3 you can find by taking -6 times -3, which is 18. Otherwise, simply just plug in for n and to get your A2, A3, or A whatever. If I want to find A17, put 17 for n, and do 2 times -3 to the 16th. All right, moving on. Problem 3. Pretty much the same thing. We got a ball bouncing. Just to be clear, this is the starting spot, and this is 1 bounce. So the height after 1 bounce is 100. There's 2 bounces, 3 bounces. The height after 3 bounces is 49. So knowing that, you might want to try to come up with the formula at this time so that you can figure out the 4th and 5th bounce. So pause it, otherwise hang with me, I'm going through it right now. A sub n equals A1 times R to the n minus 1. A1 is 100, just wrote that down here. What does this tell me? It tells me when I plug in 3, I should get 49. So I've got R to the 3 minus 1, that's R squared. I'm going to divide the 100 over. Hopefully you're okay with that move. So I got 49 over 100 equals R squared. The square root, and I get 7/10. R is 7/10. Or you could say 0.7. So now I've got my R, I've got my A1, I know the equation. Equation would be A sub n equals A1, which is 100, times 0.7 to the n minus 1. We're supposed to find A4 and A5. So do 100 times 0.7 to the 4 minus 1, and 100 times 0.7 to the 5 minus 1. Just plug those in your calculator. Here you should get 34.3. And down here, you should get 24.01. Please take note, this is just like what we did in Chapter 7. This is basically exponential decay. This would be a 30% decay situation because 0.7 is 0.3 away from 1. We get to keep 70%, we lose 30%. Okay, and last one. Read through this. Essentially what we got going on here is we're going to be finding a geometric mean to fill in spaces in a geometric sequence. Geometric mean is different than arithmetic mean. Arithmetic mean is add 2 things and divide by 2. Geometric mean is multiply 2 things and then square root it. So if you've got 2 terms of a geometric sequence and there's something in between them, all you need to do is take and multiply and square root it. And that tells you what that middle term could be. So it could be 12. It could be 48, 12, 3. And I hope you agree with that, because if that was the case, R would be a fourth. 12 over 48 is a fourth. 3 over 12 is a fourth. If I multiply it by a fourth, that's how I get from one term to the next. Well, got to be careful here, because it actually could also be negative 12. In which case R would be negative a fourth. So that's why it says what are the possible values up here of the geometric sequence, and the possible values are actually plus or minus 12. Could be 12, could be negative 12. Now be careful, because on your assignment there's some problems where maybe you've got a number and then you've got 3 blanks and then you have a number. So let's say I go with, I'll just put 48 again here to be consistent. So we use 48 and 3 up above. So you might be thinking, I can find this one by doing 48 times 3 and square rooting, which is 12. You'd be right. But can it be negative 12? The answer to that is no, because you have to multiply by the same thing all the way through. So if I took 3 times some R and then took it times R again, I have to end up with a positive. I cannot end up with a negative. So the middle term in this situation has to be positive. However, when you go to figure out the next ones, we use what's in between 3 and 12. Multiply 3 and 12, get 36. Square root of these could be plus or minus 6. If it's positive 6, r is 2. If it's negative 6, r is negative 2. And what's the pattern? Well, I'm doubling. So this one could be plus or minus 24. 12 times 2 is 24. 12 times negative 2, negative 24. So be aware of the ones that have 5 terms like this. R could be plus or it could be minus, but the middle term has to be positive. That does it for our introduction on geometric sequences. Thanks for watching. Have a great day.